Hello, Dr. Casella here, and in this video we'll be talking about incremental development. Incremental development is something that you would do when you're creating a function that is kind of complicated. And so what you do is you develop it a little bit at a time and test it each time along the way. So as you're developing the function, you keep testing it just to make sure that things are working the way you think they should be working. So that's incremental development. And in order to do that, we're going to solve a problem, something that you learned in algebra, to calculate the distance between 2 points. So I don't know if you remember this, but if you look at this first point, it's got an x-coordinate of 1 and a y-coordinate of 2. And the second point has an x-coordinate of 4 and a y-coordinate of 6. Okay, and so what we want to do is calculate the distance between those 2 points, the length between those 2 points. Well, this is these points are relatively easy it's easy to know the answer because they make a 3, 4, 5 right triangle. In other words, if this length is 3 and that length is 4 and it's a right triangle, which is the case here, then the hypotenuse has to be 5. So it's good to know the answer, so after we create our program, we have some way to check it to make sure that it's doing what we think it should. So there, see, that triangle is from those points. Okay, so let's get going. The first thing we're going to do is we will check. All right, well, let me start a new file. Okay. And so let's start by just creating the definition. We're going to call this function, we're going to define this function distance. And it's going to have 4 inputs. It's going to have the x1, y1, the coordinates of the first point, and it's going to have the coordinates x2, y2 of the second point, colon. Okay, so that's how we define the function. Now, to just make sure that we define the function properly, we'll have it return the value 0. So it doesn't matter what a person enters into the function's going to return 0. So we'll call the function. We're going to set what the function returns to the variable named d, and we'll say d is equal to distance of, and the coordinates were 1, 2 for the first point, and 4, 6 for the second point. All right, and we know that when we develop the function and it returns the correct value, it better return the value 5. Okay, so now we don't expect it to do that now because we didn't do all the math and create the program. We just want to check to make sure that we're defining a function properly and just having it return the value 0. So when this function is called distance with these inputs, the function basically ignores all those inputs and just returns 0. And we should see that because it's going to print 0. Now let's check. So let's do run. Must be saved. Okay. So we'll save it as untitled. Yes, replace it. Okay. And it ran. And you can see it returned the value 0. So far, so good. We started the process. All right, now we'll go to the next step. The next step is we will calculate the distance, okay? So we want to calculate that distance. That distance will just simply be that if I look at this point's x-coordinate minus this point's x-coordinate, that'll give me that distance, and that's 4 minus 1, which is 3. And this point's y-coordinate, which is 6, minus this point's y-coordinate, which is 2. 6 minus 2 is 4. So that'll be the next thing we check. Okay. So in our distance function, we will say that dx, that's the distance in the x, is equal to x2 minus x1. The x coordinate for point 2 minus the x coordinate for point 1. And dy will be equal to y2 minus y1. Okay? And now we'll want it to return dx comma dy. We want it to return both. So let's see, and it'll say, and then we'll see what it returns. Now it should return 3 and 4 because for those particular, for the coordinates we're entering, 1, 2, 4, 6, all right, there's 1, 2, there's 4, 6. When we enter those coordinates, we expect in x to have a distance of 3, that's x2 minus x1, and in y we expect to have a distance of 4, which is y2 minus y1. All right, so let's see. So let's save it, file, save, and run it. There it is, 3 and 4. So it returned the numbers 3 and 4 just like we wanted it to. Okay, next step. All right, so now what we'll do is, okay, we will square each value. Okay, so in order to calculate this distance, right, you have to remember the Pythagorean theorem. The Pythagorean theorem is when I have a right triangle, the length of the hypotenuse squared is equal to the sum of each side squared. Okay, so you needed to know that for this. And so that's what we'll do. We will calculate the hypotenuse squared, and we will call it d squared. All right, and d squared will be equal to dx squared, because that's the length of the one side, x, and we've got to square it, and then dy squared. That's the length of side 2, the second side, and we've got to square it. So that really, this is going to calculate 3 squared plus 4 squared. All right, and we'll have this return now instead of dx dy, because we know it did that correctly. Now we'll have it return d squared. Now, so for these numbers 1, 2, 4, 6, we know that we're going to have, we already know that dx was 3 and dy was 4. So now if I calculate d squared, it's going to return 3 squared plus 4 squared, or so we hope it should. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So when we run this program, we expect it to return the number 25. Let's check. So we'll file, save, and then run it. 25, perfect. Okay, we're on the road. So we're developing this function a little bit at a time, checking it each time, and that's the incremental development process. So the next thing is we want to calculate the hypotenuse. All right, and so the hypotenuse is, so that's the hypotenuse squared that we calculated d squared. So now all we have to do is take the square root of it in order to calculate, in order to get the length of the side. And then we're done with the problem. So we can say the hypotenuse is equal to, and then we will do math dot square root. Okay, we'll use the square root function in the math module, math dot square root of d squared. Okay, and then we'll return that. Yes, so I want to return that, so I'm going to return hypotenuse. All right, and let's see what happens. So we'll do file, save, run module, and we get an error. It says name error, math is not defined. Okay, why? What did we do wrong? Well, we forgot to import the math module. So up here we have to type in import math, math, and then hopefully now everything should work fine. So let's see, file, save, run And the answer is 5, which is what we expect because we have if we input these two coordinates, the distance between them is 5. And that's what we got. Okay, so that's the incremental development process. Bye for now.